All right, so again, today these are going to be notes that you guys are going to follow along when you're going through the PowerPoint. There are a few things that I do want you to write down. So slide all the way down to the bottom of your page, and I want you to just kind of do a little squiggly about halfway through, maybe a little bit less than half, and I want you to write this. So vertical line test. Okay, and what a vertical line test is, if no vertical line intersects the graph more than once, more than 1 point, then the relation is a function. And y'all can't see that. Ooh. All right, stand up when you have this copied down, please. All right. This is probably one of the easiest things we're going to do when we're dealing with functions, because you're just trying to determine if it's got a rule or if it doesn't have a rule. And what that means is, or if it's got a pattern, doesn't have a pattern. If you can do the same thing for every x and get the y. If you cannot, and you have to do something different for this one, to this one, to this one, to this one, then you know that it is not a relation. Okay? All right. So we're going to talk about domains and ranges. Remember, raise your hand and tell me, what is a domain? Or let me rephrase that. What value goes with domain? So domain is the what? It's the x or the x coordinate or x value. Say it that way. So then our range is obviously our what? Y value. All right. So you guys are determining what are your domains and what are your ranges. So 1, 2, 3, and 4. Stand up when you have this done. Yeah, do that in your notebook. Sorry. That's my fault. No, you're not. You're doing these in your notebook. So you're simply writing D, and then all the ones that go with the D, and then R, all the ones that go with R. All right, so let's do the first one since clearly we have left our brains at home today. So all the ones that are a X value. So what are those? So the X values, what are they?
2, 3, and
2, 3, 5. All the ones that are the range. Also, these are my X's, these are my Y's. So what are the ones that are the Y's? Joseph?
5. 3, 4, and 6.
Huh?
3, 4, and 6.
3, 4, 6. That's all you're doing for these. That's it. So you're simply writing the ones that are the X's together, the ones that are the Y's together. Stand up when you're done. All right, let's go ahead and go over these. So we did number 1. So number 2. You should end up with 2, or -2, -3, and 4. Why is there only 1 4? Why did they only put 1 4 for the domain, even though there's 4 numbers? Ariana. Yep. And then your range should be -6, 0, 3, 5. So -6, 0, 3, 5 are all your Y values. Doesn't have to be in that order, as long as you have those numbers. All right, so for number 3, someone tell me my domain. What are my domain numbers? Yep.
2, -2, -5, 0.
Perfect. And then what are my range numbers? Kira.
3, 4, 6, and 5.
Okay. So -5, -2, 0, 2, and then 3, 4, 5, 6. All right, what about number 4? Nevaeh. -3 and what? Okay. What are my range numbers? Brielle.
7, 6,
All right. So remember, a function is a set of ordered pairs where each input or domain value has exactly one output or range value. That is actually the second fill in the blank, not the first. So on your paper, this is where you're filling in the blanks. So it's not the first one, this is the second one. So a function essentially has one input to get one output. A relation is a set of ordered pairs, okay? So your ordered pairs is your relation. Thumbs up when you're ready to move on. All right, so we're gonna look at this. This is your first example on your page. Now, obviously we don't have an equation to go with these, right? But can you look at this and say, okay, this seems like it's a pattern. Like, doesn't this look like, is it technically increasing by 1? This is technically what? Increasing by 4. So what do I do to my x's to get my y's? What do you think? So what do I do to 1 to get 4? There's a couple different things. Let's come up with 1. Okay, so you can do 1 times 4. Should give you 4. All right, can you also do 1 plus 3? All right, so we have 2 options. We either have 1 times 4 gives me 4, or we have 1 plus 3 gives me 4. Let's go to the next one. 2 times 4 gives me 8. But 2 plus 3 does not give me 8. So therefore, we know that technically our function is times 4. So we're going to multiply it. 1 times 4 gives me 4. 2 times 4 gives me 8. 3 times 4 gives me 12. This has a pattern. This has the same, it has 1 input and 1 output for every one. Do you notice we multiplied every one of these by 4? So on your paper, just so you have a little bit better understanding, I want you to put, like, here's your box, and then here's your whatever, and you have 4, 8, 12. I want you to do 1 times 4 equals 4. 2 times 4 equals 8. And 3 times 4 equals 12. And I want you to highlight the times 4. Because that is what we did for every single one of these. We multiplied the x by 4 to get our y. So again, highlight your times 4. So, do you guys think this is a function? Or do you think this has a relationship? Okay, so make sure next to that information that you wrote there, you write that this is a function, and it is because it has 1 output for each input. And again, your input is your x, and your output is your y. So please make sure you write the yes, or this is a function, it has 1 output for each input on your paper. All right, thumbs up when you are ready to move on. All right, looking at this one, what do you guys think? Just by looking at the numbers. Stand up if you think this is a function. Nobody? Why? Raise your hand and tell me why you don't think this is. Brayden?
Because the 1 times 4 rule doesn't apply at the bottom.
Okay, so the 1 times 4, we can look at this. 1 times 4, that works. Well, does it work here? Does it work here? Does it work here? Does it work here? So automatically, you know, it is not a function, because if you apply a rule, it doesn't work for each one of those. The other thing, is there a pattern?
No.
There is no pattern. All right, so this is not a function, and the reason it is because the input of 1 and 2 have different outputs. And you can even put in that space right above where you wrote the vertical line test, you can also put no pattern, because the pattern is a big thing. Thumbs up when you're ready to move on. Alright, so again, the vertical line test. So this is essentially, if you have a line on a graph and you draw vertical lines on it, verticals up and down, by the way, just in case you forgot, it should never intersect that horizontal line more than once. And you'll see what I'm talking about when we get to a couple of those. Alright, so this is your line on your graph. So if you drew a vertical line from here to here, how many times does it intersect this line? One time, right? If I draw it from here to here, how many times does it intersect that line? One time. Over here, one time. So, using the vertical line test, we know that this is what? It is a function, okay? So there's an example, there's an example, there's an example, there's an example. All of them only cross this line one time. So therefore, it is a function. Okay? This one. What do you guys think? All right, raise your hand and tell me why. Someone come up here and draw a vertical line on my board with their finger and see if it passes the test. All right, Ariana, come up here.
Because if you were to make a line going this way, it crosses it twice.
Right. So no matter where you put a line on there, it's going to intersect it twice, right? Okay, does that make sense to everybody? So again, this intersects that line twice, so therefore it is not going to pass that vertical line test, which means it is not a function. What about this one? Be careful with this one. Jeffrey, come up here and draw some straight vertical lines for me. Yes, sir. I'm going to walk in my room with your hood on. You got to come up here and participate. Hold on, wait. Do it slower though. So, come over here so everybody can see. So you're out of the way and draw a vertical line. So did it intersect at once?
Yeah.
Okay, do another one. Did it intersect at once? Did you go up and down? Okay, so like if we extended this line up further, draw your line again. Is it going to intersect at once? Just one time. All right, what about over here somewhere? Is that vertical? It's got to be vertical. So like, can you put one in the middle? How many times is it intersected? Just one time. So, did this pass the vertical line test? So therefore, is it a function? All right, thank you, Jeffrey. Just because it's not a straight line does all right now. Just because it is not a straight line doesn't mean that it's not necessarily a function. So you guys have to keep that in mind as well. Okay? You all right, Jeffrey? Y'all make it? All right, so here's some examples of where it's only intersecting at one time. All right. Backwards. So technically, the line is all over the place. But it should be from here to here, if I'm correct. I don't know. So what do you guys think? It's all over. All right, this is on the right side of your page. Looking at number 1. What do you think? Yes or no? Stand up if you say yes. Stand up if you say yes. Okay? Stand up if you say no. Be prepared to justify why you're saying no. Oh, so quickly we sit down. Cam, why is this a no? So why is this no? You're right. It is no, but why? So no, and this is what you need to write next to this. So no, and then why? Oh, sorry, wrong way. Alright, so this is a no. What's one thing that stuck out to you? There's no what? Yes. So no pattern. And technically, if we put a rule for this first one, would it work for this one? So like -3 to get 15, what would we have to do? Multiply by -5? Well, if we multiply -1 times -5, we're not going to get a +9. Okay? So that's the other thing. Look at this first relationship and see if you can figure out if it's going to work or not. So no pattern. No one input or one output. So those are the reasons you should have next to your graph on your page. Okay, so please make sure you get that in the black. You get that written down next to number 1. All right. What about number 2? What do you guys think? So look at number 2. Bless you. Stand up if you said yes. Okay. Stand up if you say no. So stand up if you say yes. So one sat down and one stood up for yes. Okay? Have a seat. Stand up if you said no. Alright. We're going to talk about it. So 1, you should see a pattern here, right? The other thing you should notice is this and this are the same. Okay? -2 or -3, 2 is the same as -3, 2. Okay? And in order for the y's to have a pattern like that, you have to have a function that works. Like you have to have something times x will give you that y. Okay, so this is yes. It's because it has a pattern. And it's the opposite of this. So it'd be pattern and 1 input for 1 output. So that's the reasoning. I'm going to be honest with you. I did not do the math to find out, if you want me to just be 100% honest. Because I was like, if you find the equation that applies to that, I will give you extra credit. What?
So if it has a pattern, it doesn't matter about the math?
Technically. Because remember, like, your line is not always going to be straight. And guys, this is just a teeny part of moving into functions and y-intercept. So like, just being able to say, okay, this is a line that goes like this and it's an actual function, that's really what you need to be able to understand. What rule is it?
The input output.
What's your what's your equation?
So for y6, -1 times -6 to the 6, -2 times -6 would equal to +12 to the 4. So it ain't making sense.
But are you sure it's that simple? Like, remember, equations are not always just this times this, right? Sometimes we have this x plus y equals whatever. So it's not always just as simple as the very first one that we did. So it's a little bit more complicated than just multiplying this to get that. What?
It's just gonna start over. It's gonna be like -3, 2, -2, 4, -1, 6, -3, 2. It's gonna start over.
Okay.
That's why.
Yes.
What is going to be the biggest part in the application?
Do I care about the EOG right now? I just care about y'all learning functions.
There's a bunch.
All right, next. Looking at 3. What are you using here? Are you using the tables or are you using the vertical line test? Vertical line test. So looking at 3.
Yes.
Stand up if you think that this is a function. Be prepared to explain. All right, Nico, why is this a function? Come prove to us that this is a function. Okay. All the way across it? So there, there, there. Perfect. All right, so this is a yes. All right, and it passes the vertical line test. And what I would do on your papers, I would just draw straight lines, like 2 or 3, maybe 4 of them. Just drawing them straight up and down so that it shows that it doesn't intersect except for once. All right, what about 4? Stand up if you said yes. Stand up if you said no. Be prepared to explain. You're not sure, Nevaeh? Okay, Nevaeh, come up here and I want you to draw. Come on. I want you to draw a line from above the top of the circle to below the bottom of the circle. Did it intersect more than once? So does it cross this line more than once? No? All right, draw your line again. Did it cross it more than once? Yes. Okay, so if it crosses it more than once, we know it's what? No relation. Okay. All right, please glue these in. All right, this is your homework. Alright, so I want you to not do 15 and 16, so just circle this too. Don't do 15, don't do 16. Just circle them. And all you're doing with your homework is you're just simply going through. We're about to talk about it. You're going to just go through and you're trying to determine if it is a relation. So like looking at the first one. You have -1, 5, 0, 6, 1, 7, 2, 8. What do you think is going on? Like, does it have a pattern? Does it have a rule?
Yes, they're adding 6.
So it's technically x plus 6 will give me y. That is my rule, right? And how do we make sure that that is correct? What do we need to do? Kira?
Plug it in into the equation and group stuff.
So I do -1 plus 6, that gives me 5. 0 plus 6 gives me 6. 1 plus 6 gives me 7. And then over here, 2 plus 6 gives me 8. So this is a yes. So that is how you show your work. Questions? If you want graph paper for the ones that have coordinates on it so you can plot them, that is fine. I do not care. If you don't want graph paper, you think you can do it on your own, that is fine as well. I would highly recommend you work on this until it is time to leave.
Well, you should have done it over here.
What? Yes, ma'am. Mm-hmm.